Chapter 1: Quadratic Expressions and Equations. A quadratic expression is one in which the power of one term is 2. A general quadratic expression is given as ax squared plus bx plus c. In this expression, x squared and x are called terms. X squared is the quadratic term and x is the linear term. A and b are coefficients. A is the coefficient of the quadratic term. It is also called the leading coefficient. B is the coefficient of the linear term. It is also called the linear coefficient. And C is called the constant or the constant term. For example, in an expression like 3x squared plus 4x minus 8, 3 is the leading coefficient, 4 is the linear coefficient, and minus 8 is the constant. Keep these definitions in mind. We will be using them throughout this chapter. In Form 2, we learned how to factorize quadratic expressions where the leading coefficient was 1. For example, x squared minus 3x plus 2. We said you look for two numbers, say a and b, such that a plus b will give us the linear coefficient, and then a times b will give us the constant term. In this case, it would be minus 1 and minus 2. Minus 1 plus minus 2 is minus 3, and minus 1 times minus 2 is plus 2. We then rewrite the expression breaking the linear coefficient into the numbers we've just chosen. And so we will have x squared minus 2x minus x plus 2. And then we factorize the first two, x into x minus 2, and then the other two, minus 1 into x minus 2. X minus 2 is common in both brackets, and so we take one of them. So you have x minus 1 times x minus 2. We've done this before. In this chapter, we will factorize expressions where the leading coefficient is greater than 1. In some cases, we can reduce the leading coefficient to 1 by first factorizing the expression. For example, if you had 3x squared minus 27 plus 24, we can factorize this expression using 3 first. That is 3 into x squared minus 9x plus 8. Notice we are factorizing 3 out and not dividing by 3 because this is an expression and not an equation. If we had 3x squared minus 27x is equal to 24, then we can divide both sides of the equal sign by 3. But in expressions, we don't have an equal sign, and so we factorize. Alright, let's get back to our expression. Now we can factorize the quadratic expression inside the bracket. X squared minus 9x plus 8. We find the two numbers. A plus b should give us minus 9, and the same a times b should give us 8. Those numbers are minus 8 and minus 1. So we rewrite the expression x squared minus 8x minus x plus 8. Factorize the first two, x into x minus 8, and then the other two, minus 1 into x minus 8. X minus 8 is common in both brackets, and so we take one of them. So we have x minus 1 times x minus 8. But now you remember to put 3, and so our answer is 3 into x minus 1 times x minus 8. In certain other cases, the leading coefficient does not factorize. For example, 3x squared plus 4x plus 1. And so we proceed as follows. We find two numbers a and b such that a plus b is equal to the linear coefficient. In this case, a plus b should give us 4. Also, a times b should be equal to the product of the leading coefficient and the constant term, that is A times C. In this case, A times B should give us 3 times 1, that is 3. And so we have A plus B should be equal to 4, and A times 3 should be equal to 3. These numbers are 1 and 3. And then we proceed as usual. We break the linear coefficient so that we have 3x plus x plus 1. And factorizing the first two, we would have 3x into x plus 1, and then the other 1 into x plus 1. That would give us 3x plus 1 times x plus 1. Notice that you could also have broken the linear coefficient as 3x squared plus x plus 3x plus 1. Then we factorize the first two, x into 3x plus 1, and then the other two, 1 into 3x plus 1. And finally we have x plus 1 times 3x plus 1. It's the same thing. Another example, 2y squared plus 21y plus 10. Find two numbers such that a plus b is 21 and a times b is 20. Those two numbers are 20 and 1, or 1 and 20. We rewrite the expression breaking the linear coefficient. We have 2y squared plus 20y plus y plus 10. Factorize 2y into y plus 10, then 1 into y plus 10, and finally we have 2y plus 1 times y plus 10. 8a squared minus 10a minus 3. A plus b should be equal to minus 10. A times b should be equal to minus 24. Those two numbers are minus 12 and 2. Rewrite the expression 8a squared minus 12a plus 2a minus 3. Factorize 4a into 2a minus 3, then 1 into 2a minus 3. That gives us 4a plus 1 times 2a minus 3. Next item, perfect squares. Now 2 squared is equal to 4, 3 squared is equal to 9, 5 squared is 25, and 12 squared is 144. The numbers 4, 9, 25 and 144 are called perfect squares. They have perfect roots, unlike numbers like 10, 3 and 6 whose square roots have decimals. Equally, we have perfect squares in quadratic expressions. For example, x plus 1 squared when expanded will give us x squared plus 2x plus 1. Also, 2x plus 2 squared when expanded will give us 4x squared plus 8x plus 4. The two expressions, x squared plus 2x plus 1 and 4x squared plus 8x plus 4, are perfect squares. For example, show that the following are perfect squares. A, x squared plus 6x plus 9. To do that, we simply factorize the expression. So we find two numbers a and b such that a plus b is 6 and a times b is 9. Those numbers are 3 and 3. We rewrite the expression x squared plus 3x plus 3x plus 9. Factorize x into x plus 3, then 3 into x plus 3, and we shall have x plus 3 times x plus 3, which is also equal to x plus 3 squared, and so the expression is a perfect square. B, 4x squared plus 12x plus 9. Two numbers a plus b should be equal to 12 and a times b should be equal to 36. Those numbers are 6 and 6. Rewrite the expression 4x squared plus 6x plus 6x plus 9. Factorize 2x into 2x plus 3, then 3 into 2x plus 3. Then get 2x plus 3 times 2x plus 3. That is also equal to 2x plus 3 squared. And so the expression b is also a perfect square. (16x squared minus 8x plus 1). A plus b should give us 8 and a times b should give us 16. Those numbers are minus 4 and minus 4. Rewriting the expression 16x squared minus 4x plus 1. Factorizing 4x into 4x minus 1, then minus 1 into 4x minus 1. We finally have 4x minus 1 times 4x minus 1, which is equal to 4x minus 1 squared. And so the expression 16x squared minus 8x plus 1 is a perfect square. Consider the perfect squares we've just had. X squared plus 6x plus 9, 4x squared plus 12x plus 9, and 16x squared minus 8x plus 1. In a perfect square, the product of the leading coefficient a and the constant term c equals to the square of half the linear coefficient b. That is, a times c is equal to a half b squared. If we expand that, we have a times c is equal to b squared over 4. Let's see whether that is true in our case. The first expression, x squared plus 6x plus 9. A is 1, b is 6, and c is 9. 1 times 9 should be equal to 6 squared over 4. And so 9 should be equal to 36 over 4, and that is true. The second one, a is 4, c is 9, and b is 12. 4 times 9 should be equal to 12 squared over 4, and that is true. The third one, 16 times 1 should be equal to minus 8 squared over 4, and that is 16 should be equal to 64 over 4, and that is true. And so if any of the three is missing, it can be calculated from the relationship. Let's take an example. What must be added to x squared plus 8x to make it a perfect square? And so the missing term is c. From the expression ac is equal to b squared over 4, c is equal to b squared over 4a. That is 8 squared over 4 times 1, and it will give us 16. And so 16 should be added to the expression to make it a perfect square. X squared plus 8x plus 16 is equal to x plus 4 squared, and is therefore a perfect square. What must be added to 24x plus 16 to make it a perfect square? In this case, a is missing. From a times c is equal to b squared over 4, a is equal to b squared over 4c. That is 24 squared over 4 times 16, and that will give us 9. So we must add 9x squared to make it a perfect square. So we would have 9x squared plus 24x plus 16, that is equal to 3x plus 4 squared. Finally, what must be added to 9x squared plus 4 to make it a perfect square? In this case, b is missing. From the expression a times c is equal to b squared over 4, b is equal to the square root of 4ac. That is equal to 4 times 9 times 4. That is the square root of 144, which is plus or minus 12. We either add minus 12x or 12x. Either way, it will be a perfect square. 9x squared plus 12x plus 4 is equal to 3x plus 2 squared. Also, 9x squared minus 12x plus 4 is equal to 3x minus 2 squared. Next, solving quadratic equations. Now, the difference between equations and expressions is the equal sign. Equations have equal signs, expressions don't. We solve equations, but we simplify expressions. 6x squared plus 5x minus 1 is a quadratic expression. When we add an equal sign, it becomes an equation. In this equation, we can solve for x. Quadratic equations are solved by either factorization where possible or by completion of square. For this case, 6x squared plus 5x minus 1 is equal to 0. We factorize the left hand side. A plus b should give us 5. A times b should give us minus 6. The numbers are minus 6 and 1. Break the linear coefficient. 6x squared minus 6x plus x minus 1 is equal to 0. Factorize 6x into x minus 1, then 1 into x minus 1 is equal to 0. We have 6x plus 1 times x minus 1 is equal to 0. Now at this point, either 6x plus 1 is equal to 0 or x minus 1 is equal to 0. If 6x plus 1 is equal to 0, then x is equal to minus 1 over 6. If x minus 1 is equal to 0, then x is minus 1. Quadratic equations always have two answers. However, in certain cases, the equation may not factorize. For example, x squared plus 7x minus 4 is equal to 0. The left side cannot factorize because you cannot find a and b such that a plus b is 7 and a times b is minus 4. Those numbers don't exist. In such cases, we use completion of square method. Consider these expressions. X squared plus 4x plus 4, x squared plus 6x plus 9, and x squared minus 12x plus 36. All these are perfect squares and their leading coefficients is 1. For perfect squares with a leading coefficient of 1, then the constant term is equal to the square of half the linear coefficient. That is, c is equal to a half b squared. To solve a quadratic equation, we make it a perfect square by introducing a half b squared on both sides. In that case, we must first make the leading coefficient 1. For example, x squared plus 6x is equal to 4. We first add a half b squared on both sides. In this case, b is 6. So we shall have x squared plus 6x plus 6 over 2 squared is equal to 4, and then we add 6 over 2 squared to that side. We shall have x squared plus 6x plus 3 squared is equal to 4 plus 3 squared. We take x squared and 3 squared and put them together. So we have x plus 3, everything squared, is equal to, when we finish the right hand side, we shall get 13. To remain with x plus 3, we find the square root of both sides. So we shall have x plus 3 is equal to, the square root of 13 is plus or minus 3.61. So if we take the positive, x plus 3 is equal to plus 3.61. It means x will be 0.61. If we take the negative, x plus 3 will be equal to minus 3.61, and therefore x will be equal to minus 6.61. Another example, 3x squared plus 12x minus 5 is equal to 3. We first take 5 to the right hand side, so we have 3x squared plus 12x is equal to 8. Make the leading coefficient 1 by dividing everything by 3. We remain with x squared plus 4x is equal to 8 over 3. Then we add a half b squared on both sides. B in our case is 4. So we shall have x squared plus 4x plus 4 over 2 squared is equal to 8 over 3 plus 4 over 2 squared. That will give us x plus 4x plus 2 squared is equal to 8 over 3 plus 2 squared. We take x squared and 2 squared together. So you have x plus 2, everything squared, is equal to 20 over 3. 8 over 3 plus 2 squared will give us 20 over 3. To remain with x plus 2, we find the square root on both sides. So we get x plus 2 is equal to the square root of 20 over 3. The square root of 20 over 3 is plus or minus 2.58. So we have x plus 2 is equal to plus or minus 2.58. If we take the positive, x plus 2 will be equal to 2.58 and x will be equal to 0.58. If we take the negative, x plus 2 is equal to minus 2.58 and therefore x is equal to minus 4.58. One more, 2x squared minus 8x minus 7 is equal to 0. We take minus 7 to the right hand side. We have 2x squared minus 8x is equal to 7. We divide everything by 2 to make the leading coefficient 1. And so we shall have x squared minus 4x is equal to 7 over 2. Next we add b over 2 squared. B in our case is minus 4. So we shall have x squared minus 4x plus minus 4 over 2 squared is equal to 7 over 2 plus minus 4 over 2 squared. Then we have x squared minus 4x plus minus 2 squared is equal to 7 over 2 plus minus 4 over 2 squared is 4. Then we take x squared and minus 2 squared. So we have x minus 2, everything squared, is equal to 7 over 2 plus 4 should give us 7.5, that is 7.5. We find square root of both sides and we remain with x minus 2 is equal to plus or minus 2.74. If we take the positive, x minus 2 is equal to 2.74, x will be equal to 4.74. If we take the negative, x minus 2 is equal to minus 2.74, then x is equal to 0.74. Next, the quadratic formula. Now, the general quadratic equation is of the form ax squared plus bx plus c is equal to 0. Let's solve for x by completing the square. The first thing we do is take c to the right hand side. So we have ax squared plus bx is equal to minus c. To get the leading coefficient to be 1, we divide everything by a. And so we have x squared plus b over ax is equal to minus c over a. Now we add b over 2 squared to both sides. Notice in our case, b, the coefficient of x, will be b over a. And so we find a half of that and then we square. So we shall have x squared plus b over ax plus b over 2a squared. That is equal to minus c over a plus b over 2a squared. So on the left hand side, we take x squared and b over 2a squared. So we shall have x plus b over 2a, everything squared, is equal to minus c over a plus, if you expand b over 2a squared, you will get b squared over 4a squared. We can first complete the right hand side. We have minus c over a plus b squared over 4a squared. The LCM of a and 4a squared is 4a squared. 4a squared divided by a is equal to 4a times minus c will give us minus 4ac. And then 4a squared divided by 4a squared is 1 times b squared will give us plus b squared. We can rearrange that to have b squared minus 4ac over 4a squared. So we equate that to the left hand side. X plus b over 2a squared is equal to b squared minus 4ac over 4a squared. We find square root on both sides. The square root of 4a squared is 2a, and that can be completed like that. So we have x plus b over 2a is equal to square root of b squared minus 4ac over 2a. We take b over 2a to the other side, and we shall have x is equal to minus b over 2a plus or minus square root of b squared minus 4ac over 2a. We have a common denominator 2a, and so we shall have x is equal to minus b plus or minus square root of b squared minus 4ac over 2a. This is the quadratic formula and can be used to solve the quadratic equations for the value of x. We take an example. Use the quadratic formula to solve 5x squared plus 8x minus 2 is equal to 0. A will be equal to 5, b is equal to 8, and c is minus 2. X is equal to minus b plus or minus square root of b squared minus 4ac, everything over 2a. We substitute in our values. X is equal to minus 8 plus or minus square root of 8 squared minus 4 times 5 times minus 2 over 2 times 5. That is equal to minus 8 plus or minus square root of 64 minus 40 over 10. That is minus 8 plus or minus square root of 104 over 10. That gives us 8 plus or minus 10.2 over 10. Minus 8 plus 10.2 over 10 will give us 0.22. If we take the negative, minus 8 minus 10.2 over 10 will give us minus 1.82. Next, solving simultaneous equations. Now, simultaneous linear and quadratic equations are best solved by substitution. For example, solve 4x squared minus y squared is equal to 5 and 2x plus y is equal to 1. Now the first equation is quadratic, the second is linear. We can make y the subject of the linear equation. So we have y is equal to 1 minus 2x. Now we substitute this in equation 1. So we have 4x squared minus y now is 1 minus 2x squared is equal to 5. If you expand 1 minus 2x squared, you will have 1 minus 4x plus 4x squared. Hope you know how to do that. So we shall have 4x squared minus 1 minus 4x plus 4x squared is equal to 5. We get 4x squared, if we open that bracket, minus times 1 is minus 1. Minus times minus 4x is plus 4x. Minus times plus 4x squared is minus 4x squared, and that is equal to 5. So we get minus 1 plus 4x is equal to 5. 4x is 6 and x is equal to 3 over 2. Next, quadratic graphs. Quadratic graphs are obtained by plotting chosen values of y against the corresponding values of x. For example, for an equation y is equal to x squared minus 2x minus 3, we get a table of values for x and y. In quadratic graphs, we need a range of values. For example, in this case, let's take the values of x from minus 2 to 4. We write it as minus 2 less or equal to x less or equal to 4. When x is minus 2, substituting in the equation, y will be 5. When x is minus 1, y will be 0. When x is 0, y will be minus 3. When x is 1, y will be minus 4. When x is 2, y will be minus 3. When x is 3, y will be 0, and when x is 4, y will be 5. And so we plot the points minus 2, 5, minus 1, 0, 0 minus 3, 1 minus 4, 2 minus 3, 3, 0, and 4, 5. And then we join the points with a free hand to obtain a smooth curve. This is the kind of graph you'd expect. This kind of a graph is called a parabola. When the leading coefficient is positive, like in our case, the graph faces upwards. When it's negative, the graph faces downwards. The highest and the lowest points are called the turning points of the graph. Let's now draw the graph for y is equal to minus x squared minus 2x plus 8 for the range of values of x from minus 5 to 3. Table of values. When x is minus 5, y is minus 7. X is minus 4, y will be 0. X minus 3, y will be 5. X minus 2, y will be 8. Minus 1, y will be 9. x0, y will be 8. x1, y will be 5. x2, y will be 0. And x3, y will be minus. We plot these points and we get this kind of a graph. Next, graphical solutions of quadratic equations. Now, we often use the quadratic graphs to solve quadratic equations. For example, in our first graph, y is equal to x squared minus 2x minus 3, we can use the graph to find x squared minus 2x minus 3 is equal to 0 and x squared minus 2x is equal to 2. To solve the first one, we subtract it from our equation for the graph. Y is equal to x squared minus 2x minus 3. Then we rewrite the second equation. 0 is equal to x squared minus 2x minus 3. When we subtract the 2, we'll get y is equal to 0. And so we go to the graph and find the values of x when y is equal to 0. These are points on the x-axis. We have x is equal to minus 1 and x is equal to 3. This is the solution. For the second one, x squared minus 2x is equal to 2. We write it to have 0 on the right hand side. So we have x squared minus 2x minus 2 is equal to 0. Now we subtract it from our equation. And if we do that, we'll get y is equal to x squared minus x squared is 0, minus 2x minus minus 2x is also 0, minus 3 minus minus 2 is minus 1. And so y is equal to minus 1. We find the values of x where y is equal to minus 1. And that is approximately minus 0.7 and 2.7. To solve simultaneous equations using the graphical methods, we simply draw both graphs on the same axis. In simultaneous equations, one equation will be quadratic and the other will be linear. For example, in our second graph, the graph had the equation y is equal to minus x squared minus 2x plus 8. We can use the graph to solve a simultaneous linear equation like y is equal to half x plus 2. We just need to plot the line y is equal to half x plus 2 on the same axis. We choose two values of x and calculate the corresponding values of y. Plotting these points, we obtain this straight line. The graphs intersect at 2 points, so we read the values of x at these points of intersection.
I love that math generally has initially clear and precise answers, that you know when you know it and you know when you don't know it. As you get farther on in it, the answers are not so clearly in the back of the book, but initially math has answers, clear answers. Sometimes they're hard to find, but that clarity. The second thing I love about math is it's a puzzle-solving kind of. If I can figure it out, and the joy of figuring it out, the kind of sense of accomplishment, the sense of excitement when you get it, the challenge of trying to get it, it's that puzzle-solving kind of thing that I really, really like.